Properties of exponents, part 2. So number 1 says, use the pattern of the table to help determine the exponent properties of 0 and negative exponents. So 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. So the pattern that you might notice as we're kind of going up of increments of 1 is that it's multiplying by 2. We're multiplying by 2 every time we're going up. So as we go backwards, the pattern that's actually happening is a division by 2. Let me erase all this. Is a division by 2. So as we're going backwards, we're dividing by 2. And this is going to help us determine the properties when we have a 0 or negative exponent. So 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is just 1/2. I'm just going to leave it as a fraction. 1/2 divided by 2 is 1/4. Or we can even call this, and this is going to help us with our rule, 1 over 2 to the second. And I'm going to call this one 2 to the first. 1/4 divided by 2 is 1/8. Or we can even call this 1 over 2 to the third. 1/8 divided by 2 is 1/16. Or I can even call this 1 over 2 to the fourth. So let me kind of highlight these ones. So that's kind of interesting. Let me look at 3 now. So with 3, the pattern is multiplying by 3. So if we go backwards, actually dividing by 3. Well, 3 divided by 3 is 1. 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. Or I could really write this as 1 over 3 to the second. 1/9 divided by 3 is 1/27. Or I could even write this as 1 over 3 to the third. And 1/27 divided by 3 is 1/81st, which I could write it as 1 over 3 to the fourth. So let me highlight those as well. So the one big thing, what you notice here, is that when you have something the 0th power, it equals 1. That's a pattern we see here. Anything to the 0th power is 1. And we could have done the same exercise with 5 or 6 or any other number. Anything to the 0th power is 1. So that's the 0 exponent property. So I'm going to write that there. Anything to the 0th power is 1. Now, when we get into negative exponents, the pattern that you might be seeing is, like, for instance, 3 to the negative 1 was 1 over 3 to the positive 1. 3 to the negative 2 was 1 over 3 to the positive 2. 3 over negative 3, or 3 to the negative 3 was 1 over 3 to the positive 3. And that was just kind of the same pattern with the 2's. So x to the negative a is 1 over x to the positive a. That's the negative exponent rule. So let's apply some of these. Number 2 says, rewrite the following expressions in an equivalent form without 0 negative exponents. So again, anything to the 0th power is 1. This is 1. This whole thing is raised, on B, the whole thing's raised to the 0th power, so it's 1. On C, the whole thing's raised to the 0th power, it's 1. Even D is 1. The entire thing's raised to the 0th power, it's 1. E, C to the negative 4, would be 1 over C to the positive 4. F is similar, we just got 2 variables. That'd be x to the negative 7 would be 1 over x to the 7, and y to the negative 2 would be 1 over y to the 2. So this would be 1 over x to the 7, y to the 2. They would both be on the denominator. They're both negative. On G, the only one that's negative is J. So the K stays up, K to the 6. I don't even have to write the Z because Z to the 0 is 1. So it's just 1 times K to the 6th, which is just K to the 6th. But the J goes to the denominator because it was negative. J to the negative 5th would be 1 over J to the positive 5. Therefore, the J to the 5th is on the denominator. H is similar. 6 stays up, so does H to the 4th. W goes down. I is kind of different. So I have an x to the negative 3 on the numerator. That's going to go down. Become x to the positive 3 to the denominator. But when you have it on the denominator, that's going to come up since it was negative. So if it's on the numerator and it's negative, it's going to come down. If it's on the denominator and it's negative, it's going to come up. So here we're going to have c to the first. B2 stays. It's not negative at all. It's just going to stay. And A7's down. With k, there's a different sort of exponent rule with negative exponents that we'll get to, that we'll kind of see here that you can use. But we can also just kind of use the exponent properties we've been using. If I multiply that negative 2 in there, that's going to be b to the negative 10, and that's going to be d to the negative 12. And then they would flip because they're both negative. So same thing here. R to the negative 20, b to the negative 15. Both negative, going to flip. So those are all the exponent rules we learned in 1.1 was a few exponent rules, and then we just learned the negative exponent rule and the zero exponent rule. So now we're just going to apply them all. So I'm going to run through all of these actually on this page, and then maybe do a decent amount on the next page, and then I'm going to let you finish the final page of this lesson. So these are all the laws of exponents, okay? So we can reference this chart if we need to. So number 3 says simplify the following exponential expressions using the law of exponents. So x to the 5th times x to the 9th. In this situation, we add the exponents. This is x to the 14th. On b, it's the same. Just don't let those parentheses confuse you. It's still 5x to the power of 1/2 times, 5h to the power of 1/2 times 2h to the power of 3/4. So we can multiply the coefficients. 5 times 2 is 10. And it's the exponents that we add. It's the 1/2 plus the 3/4. And I can just use my calculator for that, or you can do it by hand. 1/2 plus 3/4, that should be 5/4. On C, when we have a power raised to another power, we multiply the exponents. So we do 3/2 times 4/5. Well, 3/2 times 4/5 is 6/5. So this would be p to the power of 6/5. On D, of course, we multiply the exponents, but don't forget we're doing 2 to the 3rd power. It's 2 to the 3rd power. So 2 to the 3rd power means 2 times 2 times 2, which is 8. And this is going to be b to the 15th. 5 times 3 is 15. On letter E, we subtract the exponents. This is going to be x to the 4th. We divide the coefficients on F. 18 divided by 6 is 3. 9, and then we subtract the exponents. 9 minus 7 is 2. G, we're just raising it to the power, so it's that multiplication, except we just got 2 variables there. So we're going to have a to the 8th, b to the 6th. This is similar, just don't forget to multiply it to the denominator's exponent as well. X to the 21 on the top, and then 3 times 1/6. Again, you can use the calculator if you don't, or write it out. 3 times 1/6 would just be 1/2. Anything to the 0th power is 1. That's always easy. This we can convert into 1 over x to the positive 6. And we recently talked about this. You know, the d to the 5 will come up because it's negative. C to the 2 will come down. This one, you can take a couple different approaches. You can either use either of these properties here. This one you can use that one too. But I kind of like to just multiply the negative 3 in first. So this can be a to the negative 6, and then b to the negative 21, and then flip them. So those are all the exponent properties involved. Now, let me, just because I've kind of mentioned this a couple times. So this is another kind of rule you can do. If you have a negative exponent, you can flip it first and then bring it in. So what you could do, I'm going to do it in blue, a different color. You could go b to the 7, a to the 2, flip it first, and then change that 3 to a positive. and get b21a6. That's another way you could approach the problem. Is deal with since it was a -3, you can flip them, turn it to a +3, and then do it that way. Notice it's the same answer. But you can do it any way you want. Erase that really fast. So those are all the exponent rules. Now, number 4, bunch of problems for you to try. It's combining all the rules. So let me just if you're okay, go ahead, do it. But I'm going to go ahead and I'm going to try to go through. Maybe I'll be able to do the entire first page here. So again, this is just going to combine a few rules. So so here we go. We're going to do this part first. We're going to multiply there. That's going to be x to the 20. And then we add them together. That's going to be x to the 23. I'm going to do this part first. So 3 to the second power is 9. And then 5/2 times 2 is just 5. I still have my a to the 3. So the a to the 3 and the a to the 5 would make a to the 8th. So I have 9a to the 8th. On C, I'm going to do 3 to the 4th power. So 3 to the 4th power is 81. 3 times 3 times 3 times 3 is 81. And then the 5 times the 4, that'd be C to the 20. And then the 3/8 times 4, 3/8 times 4 is going to be 3/2. And that's it. Since this one has a exponent, that parentheses, we'll deal with that. So the 3 is going to multiply in. That's x to the 15th. It's going to be y to the -6. Whoops. And then I still have this one over here. I'm going to rewrite. So the x to the 2nd, the x to the 15th, those can combine to make x to the 17th. Now the y to the 4 and y to the -6, well, remember, we're adding them together, right? 4 plus -6 would be -2. But here's the thing. The question we want final answer with no negative exponents. So since we have y to the -2, that's going to shift down. And we're going to have y to the +2 on our denominator. E, 14 divided by 7 is 2. A to the 9th divided by a to the 8th. Remember, we subtract the exponents, just it's going to be a to the 1st. So I don't really need to write a 1 exponent. And then the 7/8 minus 1/8 would be, 6/8, which simplifies to 3/4. So 7/8 minus 1/8 is 3/4. That's all you can do there. F, no coefficients. We can just do the 5 minus the 8, which is -3. And then the 11 minus 7 is 4. Since we have a -3 as our exponent, that's going to shift to the bottom. So I'm going to have y to the +4 over x to the 3. G and H is just 1 because they're all, the entire thing's raised to the 0th power. Let me do a couple more. A few more, actually. So 3 to the 2nd is 9. The 3 times the 2, the x to the 3rd to the 2nd power would be x to the 6th. And this would be y to the -8. That's the numerator. Then on the denominator, I'm going to have z to the -14. Now I do have some negative exponents to work with. I have y to the -8. That's going to come down. I have z to the -14 on the bottom. That's going to come up. But the 9x to the 6 is going to stay put. So the z14 is going to come join that. And then the y8 down there. On J, we're going to have, remember, this is x to the 1st. So the 1 times the -5, that's going to be x to the -5. -2 times -5 is +10 there. And then the -6 times -5 is going to be +30. So then the only thing that needs to move is the x to the -5. So the y to the 10 is going to be alone up there. That's not moving. The z30 is going to stay as well. And I'm just going to, the x5 is going to come and join z to the 30. Let me do a couple more. I know I'm doing a lot here. So 2 to the 5th, so I'm on k now. 2 to the 5th is 32. 2 times 2 times 2 times 2 times 2 is 32. 1/3 times 5 would be 5/3. And then I'd have c to the 10th. Now I'm going to rewrite this second one, but I'm actually going to leave out that w to the 0 because w to the 0 is just 1. So this is just kind of like a 3 times 1. It's just 3. So I don't even need to write that w to the 0. So I'm not going to. So the 32 times the 3, that's 96. The w to the 5/3, I'm going to rewrite, has nothing to combine with. But now I have the c to the 10 and the c to the negative 13. Well, I'm going to add 10 plus negative 13 would be negative 3. So I'm not quite done yet because I still have a negative exponent. And it's that negative 3. So the 96w5 to the 3rd is going to stay on the numerator. And then that c3, I'm going to have a c3 on the denominator. Let me show you one last one. So negative 7 times negative 2 is 14. 3 times negative 2 is negative 6. So what I handled was this first one because it was raised to a power. Now that second parenthesis is not raised to a power, so there's nothing to do with that one. I'm just going to rewrite it. And now I can add my exponents. So the 14th and the 2 for the a would be a to the 16th. B to the negative 6 times b to the 2 would be, so negative 6 plus 2 is negative 4. And again, it's not finished because I want my final answers to have no negative exponents. So I'm going to have a to the 16th is going to stay in the numerator, but the b to the 4 is going to come down because it was a negative 4. So these problems can be quite challenging. So go ahead. You can try this last page. Okay, you can try all these. I know they can be tough, but just do your best.